Good morning, students. Welcome to the online classes, St. Anthony's and St. Peter's High School, Sangari. Today we are in day 3 session from friction lesson 8th class. See, in the last classes we have studied about the types of frictions, static friction and sliding friction we have observed in several activities. And now today we are going to learn that in this session we will be learning about why static friction is called as self-adjusting friction, and also on what factors friction depends and what factors frictional force doesn't depend. We will be learning in this activity, in this session. Sorry. Let's move on to the session. Let me take the example of a bench. Now, I have a bench. I want to push this bench alone. If I want to push this bench, I need to apply some force on this, right? But I am unable to push with the little force what I have applied on this bench. What to do? See here, two things you have to observe. When I am trying to push the bench, my force is applied on the body. On this bench, I am applying some force F, and the surface of the ground is opposing my motion of the table, and I call this opposition force as frictional force. Now, in order to increase I want to push this bench, so what I do? I will apply more force. Even though when I am applying more force, I have increased the force here. Though my force is increased, the object is not moving. That means the frictional force offered is also increased here. When I am pushing, I am applying more and more force. Frictional force also started increasing. It means that, how do you know that the frictional force has been increased? Take the example of this wall otherwise. Now push the wall with some force. The wall is in rest position. It means applied force and the frictional force both are balanced, or the net force is 0, I can say. Now let me apply more and more force. When I apply more and more force, also my wall is not moving. What do you think? When I have applied more force, suppose let me take the example. For example, I have applied 10 newtons of force. My wall is in rest position. It means net force is 0. When net force can be 0, when the frictional force balances my applied force. That means my frictional force also it should also be 10 newtons in order to balance my applied force, right? Then only my body will be in rest position. Now when I apply some force on this wall, my wall is in rest position. It means it is offering some friction which is equal to my applied force. Now in the second situation, I apply more and more force. Let my applied force change it to 20 newtons. When my applied force is 20 newtons, let's suppose, as I don't know whether friction force increases or decreases, originally my friction force was 10 newtons. Now in the second case, my applied force has increased to 20. Now with what force it will move? 20 minus 10, 10. With 10 newtons of force, the body should move, but my wall is not moving. Though my applied force has been increased, my wall is not moving. What do you think? What do you think is happening here? Definitely, your frictional force must again balance your applied force. Then only the body will be in rest, otherwise it won't. So, as I have increased my applied force, still the body is at rest, it means that my 20 newtons of force is balanced by the frictional force. When it can balance? When the frictional force again changes into increases to 20 newtons. From 10 it has to increase to 20 newtons. I ask my all the classmates to help me in pushing the wall again. Now what is the force applied by all of my classmates now? Now it may be increased to 100 newtons because all of us will be applying some force. Then also my wall is not moving. In this situation, what do you say? Again the frictional force has been increased. So how long it will increase? It is, say, if you take a heavy wooden box or some iron made of box, whatever it is, or you take a rice bag, try to lift it, you can't. Try to apply more and more force to push it, then you can, literally it will move. And ask your friends to help, 2 or 3 of your friends, together you push the bag, you will be able to push the bag. It means that your applied force has been, if it is greater than the limiting static friction. See, static friction is not unlimited, children. It is not unlimited, it will have certain limit. How do you know? How can I say it has certain limit? Now, in the example of rice bag, try to push alone, you cannot. Try to apply more and more force, you cannot. Try to take your friend's help, definitely you can push now. What do you think? In the first 2 situations, when your force was increased, your static friction was also, your friction offered by the surface was also increasing. That's the reason I say static friction is self-adjusting, it will adjust by itself. When I try to push, when I apply my applied forces, when I am applying some force on the object, friction offered by the surface, both are same. When I say when the both will be same, as the body is in rest, I say both are same. Now my friends are helping me to push the rice bag. Now what happens? The rice bag started moving. When that happens, when the body will be in motion, when my applied force is greater than the limiting force, limiting static friction, then only the body moves. Is it clear for everybody? Hence I say, when your applied force is increasing, your friction also increases. When applied force increases, frictional force also increases. How long it will increase? Is it unlimited? No, it has certain limit. So I call it as limiting friction. And when your applied force is greater than limiting friction, the body starts moving. Now let us see on what factors does the friction depends on. On what factors the friction doesn't depend. Let's see from small examples here. I have a spring balance. Spring balance here is to measure the force applied. Now I have attached a brick placed horizontally. I have a brick which is placed horizontally. Now try to push the balance now. Now same activity if you do it and note the reading here, how much force it needs. Now how much in the same activity you place the brick vertical direction. First of all you place the brick in horizontal direction. Now you are placing vertical direction. What is the difference in these 2 cases? Area of contact is less in the second case, whereas area of contact is more. That means when you place a brick like this, for example, if I take this, the surface of this the body and the surface of my palm, see what the surfaces what they are coming into contact, it is more. But when I place this, only little area will come in contact with the surface. So here what you observe is, when you place a brick in horizontal direction or in vertical position, you will get the readings here as same. It means that your frictional force is independent of area of contact. That means your frictional force doesn't depend on area of contact. Did you understand, children? Let me say again. When you do this arrangement, when the spring balance is attached to the horizontally placed brick, and you will observe the frictional force offered here in the spring balance, you have to note it. When you note them, in these two situations, you will get the same force. It means that irrespective of the position of the brick, your frictional force is same. It means that your frictional force is independent of area of contact. Now I have another situation. Same activity, but I place another brick over the first brick. What happens when I place its weight increased? Brick on the brick. If I place 2 or 3 bricks, what happens? Its weight increases, so normal force also increases. How do I know normal force increases in this situation? How I am saying that normal force is increased here. See children, in the vertical direction you observe what is the net force acting. What is the net force acting in vertical direction? I say net force acting is 0 since as it is not moving, it is at rest. What are the forces acting on the brick here now? Its weight and normal force in upward direction. Both the forces are equal and opposite. Hence, the net force acting on the brick is 0. That's the reason the bricks are at rest. Now, I will observe, I am keeping 1 brick for the first time and the 2 bricks for the second time. And I will measure the frictional force by using the spring balance here. When I use the spring balance to measure the frictional force, in these two situations, I observe that frictional force will be increased when normal force increased. It means that frictional force depends on normal force. Suppose if I take a lightweight object, I am applying same amount of force on the lightweight object and heavier body. In both the cases, frictional force is offered, but still on lightweight objects, frictional force offered is less compared to the other heavier one. That's why I can say frictional force is proportional to the normal force. Proportional here indicates that if normal force is increased, your frictional force also increases. Coming to the next, here we will observe how frictional force is affected based on the smoothness and roughness of the surface. Let me take an inclined a table here and a sloped or inclined plane here. I allow my marble to flow down, to slope down through the inclined plane. Now the body or the ball moves, or if I can take a ball or a marble or anything, it will move very fastly and it will move long distance. It will travel more distance if the surface is very smooth. Now let me keep the cloth on that. What happens? Will the marble move very fastly as before, or will it travel more distance or equal distance in the second case when I have placed a cloth on it? Definitely it won't, because the cloth offers irregularities, it offers more friction, it opposes the motion of the ball because of the interlockings. So in order to overcome the interlockings or roughness of the surface, or when the roughness of the surface as it offers more friction, we need to apply more force to overcome that. So for rough surfaces, friction offered will be more. So this is the example where we can say the frictional force depends upon nature of the surfaces also. Like same as before, when I throw a marble on the smooth surface, it flows with longer, it moves longer distances. If the same marble is made to move on the sand, on the soil, it travels less distance comparatively with the smoother surface because of the interlockings in the surface or ups and downs in the surface. As they get blocked and it doesn't allow the object or the ball to move forward for longer distance, and it also reduces the speed of the ball. So that's the reason the friction is offered because of the irregularities and ups and downs of the surfaces, and it will be more on the rough surfaces. Let us recap. In this session we have learned about why static friction is a self-adjusting friction. By observing the here, as the force increase, applied force is increased, your frictional force will also be increasing. That's the reason why we call it as self-adjusting force. And also we have discussed about on what factors your frictional force depend on and what factors it doesn't depend. Frictional force is independent of the area of contact, whereas frictional force is dependent on the normal force. It is directly proportional. If the normal force is increased, your frictional force also increases. Coming to the next, your frictional force also depends on the smoothness or roughness of the surfaces. More the rough surface, more the frictional force offered. That's all for this session. Thank you.